Back. Welcome back, everybody. So take two. All right. Again, I'm going to go over the warm up, and then we'll go through the homework. Just as a reminder, for the upcoming couple of days here, we will have our quiz over just section 3.5 and 3.6 on Wednesday of this week. That means that today we're going to finish up section 3.6, and this homework assignment is actually a review over section 3.5 and 3.6. I'm hopefully going to get you a good amount of time to work on that today, because the notes, it's only one page. It's just a word problem. And then we'll go through it and then hopefully give you a bunch of time to work on that. We'll go through that tomorrow. And then I've got a whole lesson worth of just more problems, more example problems to go over. Yeah. Yeah. So we'll have all of that on Tuesday, and then we'll have our quiz on Wednesday. And just so you guys know what's going on past that, we'll have our 3.5, 3.6 quiz on Wednesday, and then we will start reviewing for our Chapter 3 test. Okay? On Thursday, we're just going to go back to section 3.1 to 3.4, and I'm going to do kind of like a reteach on that stuff, because that was some stuff. Remember that last quiz? Also, if you did your retake on Friday, I have them graded and in the grade book. So I did put those in. I think it was like Saturday night that I put those in. Fun Saturday night for me. Great. No, our trick or treat was Sunday night. It was yesterday.
How was the overall score?
Man, so there's a couple houses behind. I live like right behind.
Like he said, the scores like on the replay.
Oh, I thought you were talking about like candy, like the scores on the candy. Like we got some king size candy bars. I know.
What did you dress up with?
I did not know.
A dad. So in this allotment right behind it, this is great for the video. In the allotment right behind ours, this lady came out with a basket full of king size candy bars, or $5 bills wrapped in a little like a bow.
That's not.
Wait, Mr. Laverick, you know how you were doing garage? You're at a garage sale in like my neighborhood. Do you live in that neighborhood?
No, I live in North Canton. I'm just friends with that person.
I was like, why are you
There's literally no way they're getting that.
$5. I'm serious. $5, like wrapped in a little
No
bow.
way.
I'm serious. And so they put the little basket out, and I'm like, "Sadie, grab the money. Grab the money." And she's like, "I'll take the Reese's Pieces." It's like, no, grab the money.
Grab the money and the Reese's Pieces.
My cousin went somewhere with there handing out like $10 bills and king size candy.
Oh my
But you got
gosh.
like 2 king size candy bars and a $10 bill.
How many of you guys went trick or treating? Anybody?
I mean, I did, but
I went with my little 2-year-old brother.
Well, okay, that's good.
I went to a party instead.
Did you give out the candy?
I don't live in a neighborhood where
That's okay. Yeah.
We did.
No, I gotta teach.
So how was the math score?
For the retakes?
Yeah.
Generally really good.
Okay, thanks.
what happened?
He's still
I got yelled at for printing memes on the printer.
Note to self. Don't print memes. Were they at least good memes?
They were.
Okay, quality stuff. Okay.
Tell me more.
That's okay. Okay, so let's graph this line. Now, when I say graph the line, I fear for the future. No, that's not me. It's good game, yeah. All right. Sorry, I didn't know his name. So I've got 4x plus 2y is equal to 10. If I want to solve for y, let me ask somebody here. If I want to solve for y, Gio, what's the first step in solving for y? In getting y completely alone?
You would make the x 0.
Okay, that's solving for intercepts. I see what you're doing there. He said, would you make x 0? I get that. That's solving for intercepts. I want to put this in slope intercept form. So I want to get y.
Do you do like the minus thing, like the like where you put the line and then you do the y minus the other y and then
No. You're thinking of slope.
I did it differently.
You were thinking this.
yeah, pretty much
Yeah. I think so. Maybe.
subtracted-
Danielle. Yeah. You got to subtract the 4x over to the other side. Shh. Quiet, folks. People, quiet. Because you're obviously confused. I need to get y completely alone. Now, I just heard somebody say, if you're going to solve for y, why are you moving y? Or why aren't you moving y? You want to leave y where it is. You want to leave y alone. You need to subtract everything and divide everything away from it. So you want to do that reverse order of operations to get y completely alone. That's why I'm doing my subtracting 4x. The other option people always say is to divide by 2. You don't want to divide by 2 yet. You can't break into that multiplication division yet.
Then you put down 2y equals negative 4x plus 10 and then y by 2 for each thing.
Good. Now, remember that what I'm doing there is putting it into slope-intercept form. So that's why the x should come first. That's why it should say negative 4x then plus the 10. Now, when I divide by 2, y is equal to negative 2x plus 5. Okay, now, there it is. And again, always reduce that down. Don't leave it like negative 4 over 2 or 10 over 2. Reduce it down. So now, Rose, what's my slope out of this equation?
M equals -2 and then B equals 5.
Good. Okay, so I have all of my important information pulled out. Now, Luca, where do I start? I'm going to graph now, right? I'm ready to graph. Where do I start? Gotcha. Start at the BN. Start at the y-intercept. Yeah. Always start at the y-intercept. Always start at the point, because that is the coordinate 0, 5, right? So start there. Now, 0, 5. Does that mean go up 5, right 5, down 5, left 5? Where do I go? Up 5. Good. The reason I ask that is because a lot of people tend to put it on the x-intercept instead of the y-intercept. Okay, so now, yeah, question.
I was going to say, I watched a video on how to do this, and it said for the B, it means like up and down, and for the M, it's side to side, so you just do a pattern of like every line.
Yeah, okay. Here's what I like to say. Now that I've got my slope, I'm going to use that point and that slope to generate more values. Here's what I mean by that. Okay, here's my point. -2, 1. Down 2, right 1. Down 2, right 1. How do I know I'm going down and to the right? Because it's a negative sloping line. The other option, because I could have this or this, I could go up 2 and then I go left 1. Up 2, left 1. Up 2, left 1. And there is my line. Kind of missed my points up there, but you get the idea. Okay, questions on any of that? Yeah.
No, man, I was gonna ask for a continuous or not, but then I saw you put that. So, okay.
Okay, let's go to the worksheet. I really hope the front of this was easy. I hope the front of this was easy. The back was maybe a little bit more difficult, but I hope the front of this was easy. Let me go over a couple questions from the front. What do we want to go over from the front? Give me at least 1 or 2 to go over from the front. Noah? Number 4.
Actually, number 5.
Okay, number 5. Now, why do I say that these problems are easier than the ones on the back? What's the difference between the ones on the front and the ones on the back?
Well, the ones on the front give you the X and the Y.
Yeah, it's all set up for us on the front, right? What do I mean by that? That means that the y is solved for on the front. Y is alone on the front. Y is equal to mx plus b, and all of these on the front. 6 is a little weird. Remember, 6, that's just a horizontal line, right? Any y equals is a horizontal line at that value, so -3, horizontal line at -3. But these are all set up for us where it's y equals a number. That means I should be able to just take y equals mx plus b, and there's my m, and there's my b. M is -3/4, b is 5. So I start at the b value. I think that was like my warm-up too. Didn't I start at 5? Yeah. 5. And then my slope is -3/4. Now remember, somebody said to me last period, so does the negative just go always on top with the first number? No. Remember that a -3/4 slope is -3/4, which is also equivalent to 3 over -4. All of those things are equivalent statements. So I can put the negative in the numerator or denominator. Doesn't make a difference. I could go down 3, right 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Or I could go up 3, left 4. 1, 2, 3, 1, 2, 3, 4. And then I make my line. Whoa, yikes. Try to hit the points that we got in there. If you want to bring a straight edge for your quiz, that might be a good idea. I have a bucket of rulers up there if you need one. Okay, questions? Anything else on the front that we'd like to go over? Anything else on the front? Okay, let's flip it over onto the back and let's do 2 out of these 4. Nathan?
Can you do number 8?
Yeah. So number 8 here. First one here, number 8. Again, I'm going to solve for y by subtracting 4x off the bat. Don't divide by 8. Don't do it. Just subtract by 4x. So that means I'm going to have 8y is equal to negative 4x minus 24. Now I have to finish this off by dividing by 8. I divide by 8 to each piece. So y is equal to negative 1. Now, do you see how I simplify that all the way down to negative 1/2? Negative 4 divided by 8 is negative 1/2. Can you write negative 0.5? No, that's not okay. I would take off if you write it as a decimal because slope is a fraction. Negative 1/2 x and then a minus 3. 24 over 8 is 3. Okay, right there. Okay, so I don't need to call on people. I'll just do this. M is negative 1/2. B is negative 3. Right, M is my x, number next to x, and your B is your y-intercept, the number sitting out there on the end. So I start at the negative 3, and I use my slope to generate more points. Again, I could go down 1, right 2, or I could go up 1, left 2. Okay. That's a little bit better. Remember to put arrows on the end. Always put arrows on the end. That's something that I would definitely take off for if you did not put arrows on the end on your quiz on Wednesday. Okay, one other one. What else do we want to go over? Danielle? Number 10. All right, so I would add the 2x to the other side first. Remember, do your addition and subtraction first. Now your division. Now I divide by 3. Okay, so this is, now does 2 over 3 reduce to anything?
No.
Can you say 0.67?
No.
No. You've got to leave it as 2/3. And then plus 4. So M is 2/3. B is 4. Okay, I've got a positive slope this time. The y-intercept is positive 4. My slope is 2/3, up 2 over 3. 1, 2, 3, up 2 over 3. Or I could go down 2, left 3. Down 2, left 3. And there's my line. Always start at your y-intercept and use the slope to create more points. You should always perform the check in the end. Okay, is it a correct positive or negative slope? Like, difference between 8 and 10. 8 came out as a negative slope. Do you see it as a negative sloping line? Yeah, I see the end. 10 came out as a positive slope. Yeah, it's a positive sloping line. I'm okay if you do a couple and then just make sure your line runs in the correct. That's why I say use a straight edge because it'll definitely run through. Yeah, I get it. Yeah, just do maybe like 1 or 2 on each side and then graph your line. Any other questions? Okay, let me give out the guided notes for today. Again, just one problem for today. One word problem. That's it. One word problem.
I wouldn't put one question on there because I was going to take apart 50 questions.
All right. Now, we've been talking about slope-intercept form. We know what it is. We've used it. We know how to identify it. Now what we're going to be looking at is word problems. Now, I had said earlier on back in section 3.5 that, you know, word problems lend themselves more to being standard form, right? Word problems are usually more standard form, where I have X and then the Y and then the number. However, there are some word problems out there that use slope-intercept form. I will say this as a general rule, and I am generalizing here. As a general rule, when it's in slope-intercept form, it's usually presented as a problem where I've got an initial amount and then a rate. Is everybody hearing me on that? When it's slope-intercept, usually the problem is represented by an initial amount, a starting value, and then a rate. Maybe I'm traveling at a rate of 30 miles per hour. I start 10 miles away and I'm traveling away like 30 miles per hour, whatever. That's a starting value plus an additional rate, right? Maybe I am, I'm trying to sell something, and I'm, total revenue is my y-axis, and I've already starting with some value, and I generate a particular dollar amount per thing I sell. I don't know, whatever. So I have a starting amount, and then I have a rate. That's more of a slope-intercept form. That's kind of uncommon. And I would say to you, it'll be presented to us in slope-intercept form, but we're not really using the slope and the intercept to graph. And I'll show you what I mean here with this problem. All right, we got a closet organizer. They charge an initial consultation fee plus an additional amount per hour. Right there, I'm going to stop for a second and say, then I know that this is probably going to be in slope-intercept form. Initial consultation fee plus an additional amount per, first of all, closet organizer? Really? Some people, okay. I would hate to have that job though. I would not want to organize someone else's closet. That's like not like it. So they charge an initial consultation fee plus an additional amount per hour. Right there, that's slope-intercept. That's my starting value plus a rate. So I have my initial consultation fee. That is like, okay, maybe they're coming to the house and they're going to look at everything and decide how long is this job going to take. It's like an estimate, right? They come out, they examine, they figure out what they need to buy, to organize everything, and then they'll come back and do the labor later, right? They charge $100 for that. Okay, that's like an estimate. A lot of places, like if it's a plumber or a construction service, that they're usually going to give you like a free estimate. Like if you order like a door from the hardware store, they'll come out, they'll measure everything. They're not going to charge you for that, but then they'll come out and charge you per hour for the labor. Like apparently they're going to charge you $100 just to come out, plus a $30 fee for any labor hours worked. Okay? So that's what we have. Our final charge is shown by the function f of x is equal to 100 plus 30x. I'm actually going to jump to part B and identify the slope and the y-intercept and describe their meanings. So my initial function, and I am only writing this because it's not still on my screen, f of x is equal to 100 plus 30x. Let's talk about the slope. What is my slope here? What is my slope?
30x.
Be careful. Just the 30. Just the 30. Okay, what does that mean? What does that mean within the problem? Danielle? Good, it's the fee per hour. The fee per hour. They're getting charged $30 per hour. Okay, if that's my initial fee, my fee per hour, what is my 100 representing within the context? Nathan?
Travel fee?
I wouldn't call it the travel fee. Call it what it is up top. The consultation fee, right? The consultation fee. That's probably tied into it though. Like, okay, it's time to travel, time to go out there, time to meet at that person's house. Now, if it's a consultation fee, that's the $100 consultation fee. I'm going to take it one step further and describe what the 30x also means. What does 30x mean? Not necessarily because I'm not.
Like the amount of hours.
Good. The total charge, the total hourly charge, right? That's what it means. Total hourly charge.
So is the X always gonna be total something?
Be careful. Be careful with that because it's not grand total. It's just, since I apply the X, the amount of hours, times the 30, that's just saying like the amount of labor cost. Not the initial fee, but just the amount of labor cost, right? I'm going to write that in parentheses because that's a good way to put it, the labor cost. Okay. All right, now let's go back up and graph. Anybody still need that? Okay, let's go back up and graph now. So f of x is equal to 100 plus 30x. Now, is that truly in slope-intercept form? I'm just gonna move that around just a little bit. So f of x, and then remember, f of x just is another way to say y, right? So 30x plus 100. That means, and we talked about it, m is 30 and b is 100. Now, are my axes labeled on your paper there? No. So what I'm going to do is I'm going to go and label my axes. Now be careful here. What's my x-axis label?
Total hourly charge.
Just x, not total hourly charge, just x. What is x?
Feet per hour.
Not feet. The amount of hours. Just hours. Because this has nothing to do with cost on my x-axis. That's my y-axis. This is total cost. Total charge, total cost, whatever you want to say there. Okay, now for my hours, let's just go by twos and go up. I'm sorry, not by twos. I'm going to go two blocks. 1, 2, 3, 4, 5, 6, and we can see a pattern by that. Now, take a look up here, everybody. Don't write this down just quite yet on my y-axis. Because somebody said to me, okay, let's go by tens last period. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. What's wrong with that? Why should I not? Because that fits. 100's on there. That fits. Why is that bad?
Because it can keep going.
Because it's only going to grow from there, right? It's only going to go up from there. So if I start at 100 on my axis, by 1, I'm already at 130, and I'm almost at the top of my graph. So that's not a good representation of labeling our graph here. So instead of going by tens, let's go by 20s, shall we? So 20, 40, 60, 80, 100, 20, 40, 60, 82, 20, 40, 60, 80, and we'll put 300 up there. That's going to be better. Because now my y-intercept, which is my 100, is going to go right here. Okay, now, am I going to use my slope to generate more points? I mean, that's what we have been doing. But am I going to go up 30 boxes over 1? No. I am going to go up 30 on my y-axis. And then over 1. Like, for example, going up 30, everybody look at my yellow here. Going up 30 goes this much. 1.5 boxes, because each box is worth 20. Then I go over 1. That's my next dot, right there. So it might be easier for you just to like make a little table for yourself. Or just know how much is it going to go up by each time? 30. So I'm at 130, go up 30 more, 160, go up 30 more, 190, go up 30 more, 220, 30 more, 250, 30 more, 280. Oh, it fits perfectly on my graph there. Now, do you see, I put an arrow on this side. Do I put an arrow on the left side? No, because can I go into a negative amount of time? No, I can't do that. That doesn't make sense. Can't go back in time. Not yet. So I have no arrow on my left side, but I am going to put an arrow on my right side because it could keep going past that. Does it stop at 6 hours? No, it could keep going. So there's my graph. Now, let's jump to the very end and say, okay, find the cost if the organizer works 12 hours. You know what I'm going to put this in? Fancy function notation. Guys, understand it. I'm finding f of 12. F of 12. That's really what I'm finding. F of 12. F of 12 is my cost at 12 hours. My output, if the cost is, my input is 12 hours. Okay, so that's just like saying 100 plus 30 times 12. Remember, all you're doing there when I make that notation is plugging that value in. Some people are still not understanding that from last quiz. If you want to find f of 12, all you're doing is plugging 12 into that equation. So let's do that. I've got 100 plus 30 times 12. Oh, look, it's still right there. $460. F of 12 is 460. So $460 for a 12-hour job. That's my initial consultation fee and hourly cost all wrapped into one final total. Okay? Questions about that? All right. So long, everybody. Out there on the internet.